Welcome to Notes for Matrix Algebra. So in a matrix, we have dimensions. Sometimes you might see the word order represents dimensions. Elements are the entries in each matrix. So if you had the matrix A, B, C, D, the elements are A, B, C, D. The dimensions are the number of rows by the number of columns, column 1, column 2. Notice you can count. So there's 2 rows and 2 columns. So the dimensions of this one is a 2 by 2. We also have another example of a matrix A. 1, 4, 7, 2, 5, 8, 3, 6, 9. Here we have row 1, 2, row 3, column 1, column 2, column 3. So that means we have 3 rows. So you do rows first. So 3 rows by 1, 2, 1, 2, 3 columns. So C is next. So 3 columns. If we wanted to find a specific element, we would have 1, 3, where R represents the row and 3 represents the column. So we're going to go to row 1, column 3, where they meet is the element. Again, if you had row 2, column 3, row 2, column 3, the element is 6. Equal matrices, matrices with the same dimensions and elements are equal. So if we had a matrix that has x, y, and they say they're equal, then we're going to have x equals 4, y is 2. To continue the notion of equal matrices. Addition and subtraction of matrices, where if you notice we're adding elements, if this had been a minus, we would then subtract them. So if we had 1, 2, 3, 4, 5, 6, to subtract them, you only can do it if they have the same dimensions. So this is a 2 by 3. I'm going to put a plus here. -3, -2, -1, -5, -10, -9. And you're going to add them together. So this is also 2 by 3. So 1 plus -3, -2. 2 plus -2, 0. 3 plus -1, 2. 4 plus -5 is -1. 5 plus -10, -5. 6 minus 9 is -3. Remember, you can only add if they have the same dimensions, same way with subtracting. Scalar multiplication. This represents your C. For constant, this is matrix A. So we're doing C times A. So essentially that means just distribute. So distribute will be negative 8, 0, distribute 16, 20. Okay, so to multiply two matrices, the number of columns in the first matrix, must be equal to the number of rows in the second matrix. They are, so the product exists. Make sure to check that the product exists first, or they can't be multiplied. Okay, so dimensions of this, row 1, row 2, row 3, column 1, column 2, row 1, row 2, column 1, column 2. So this is a 3 by 2, 2 by 2. It does match up. So a little trick I learned is that the number on the outside represents the number of rows in the answer. Number on the outside represents the columns on the answer. So this equals, you can make a 3-row by 2 columns with blank spaces, and then you can just fill it in. So now this is where the fun begins. So row 1 times column 1, negative 3, negative 6. I like distributing row 1 by column 1. Negative 3 and negative 6 makes negative 9. Then row 1, column 2. That would be this element right here. So 0, 0, minus 3, negative 3. Then row 2 by column 1. So 3 plus 4 is 7. Row 2, row 2 by column 2, you have 0 plus 2, that's 2. Row 3 by column 1, we have 0 plus 2 is 2. Then row 3 by column 2, we have 0 plus 1 is 1. And that's your answer. Now we're going to go over some practice problems. Are they equal? 0.25 is equal to 1/4. 2 is equal to 2. 1 is equal to 1. Negative 3 over 5 is 0.6. So yes, they are equal. Okay, so negative 1 is not. So they're not equal to. Not equal to 1. If one pair of elements are not equal, they're not equal. Okay, so this is a 2 by 1. Perform indicated operations. only if it's possible. Not possible, state reason. So a 2 by 1 and a 2 by 3. Not possible because the dimensions must be the same. So now we're going to subtract. Make sure check for dimensions first. The dimensions are the same, so we're then going to do it. So 3 minus -1 is 4. -2 minus 2 is -4. 0 minus 5 is -5. -2 minus 3 is -5. Number 5, this is the scalar multiplication, so distribute it in. That's 3, 6, -6, 9, minus the other matrix. Check for the dimensions. 2 by 2, 2 by 2, dimensions are the same, so we can add them. 3 minus 2 is 1. 6 minus 6 is 0. -6 minus -6 is -6 plus 6 is 0. Be careful on your signs. 9 minus 8 is 1. Oh, that's the identity matrix. Interesting. Okay, now we're going to solve. So we're going to have 3x, -4, -16. So 3x plus -4 equals -16. And then add the 4 to both sides. So 3x equals -12, and x is -4. Then notice that there's another variable, y. So the elements that match up with y is -7 and -1. So -1 plus -7 equals y. So -8 equals y. Okay, so we're going to set a matrix up for these. So all you do is you look down here. Whoa. And you see which one matches up. So 5, 15, 5, 15, 7, 18, 14, 0, check. 15, 33, 18, 24, 19, 4, check. B works. Okay, so we're going to determine if the product exists. Remember, columns must match up with the rows of the second matrix. So yes, product exists. This one, columns of the first matrix does not match up. So product does not exist. So make sure you test for that, because if product does not exist, you just stop right there. Just give the reasoning. Okay, now we're going to multiply a 2 by 2 and a 2 by 2. Don't block your workout. So I'm putting dimensions up here. It does check out. So now 2 rows and 2 columns in your answer. 2 rows, 2 columns. So row 1 times column 1 is -6 plus 0 is -6. Row 1, column 2 is 3 minus 2, that's 1. Row 2, column 1 is 2 plus 0, that's 2. Row 2, column 2 is negative 1 plus 0 is negative 1. Okay, now we're going to work with this one. This is a 1 by 2. This is a 2 by 1. So yes, it is possible. Our answer will have 1 row and 1 column. So 1 element basically. So row 1 times column 1, negative 8, negative 12, negative 8, negative 12 is negative 20. So this is a 3 by 2. This is a 2 by 2. So there's 3 rows and 2 columns in our answer. So 1, 2, 3 rows, 2 columns, 6 elements, same process. Negative 4 plus 30 is 26. Row 1, column 1 is 3 plus 40 is 43. 5, 2, so that's 20 plus 12 is 32. Row 2, column 2 is negative 15 and positive 16, and that's 1. 0 minus 24 is negative 24. Then row 3, column 1 is 0 minus 32 is negative 32. And that's it. These are the notes for matrix algebra.